than this computer. All right, cool. Additives, right? We talked about them a little bit. Accelerators, which basically reduce the setting time of the cement, right? So we talked about setting time, and we said that, okay, uh, the cement time, setting time shouldn't be very fast. It shouldn't be very slow as well, depending on the depths of the casing that you are cementing. It's different. So you might need to change it based on the location and based on the depths at which you want to do the cementing job. So there are accelerators and retarders that you can use for that purpose. Uh, there are extenders, which basically they reduce the density of the cement slurry. It also increased the slurry yield. Remember the definition of the yield that we had in your drilling fluid, how much basically drilling fluid with 15 centipoise basically viscosity can be make based on whatever clay that we are mixing, right? The higher the amount of drilling fluid that we can make at 15 centipoise, it means that you have higher yield, right? So this is kind of the same type of definition here for cementing as well. But there are basically these, cementing. There are other additives as well. Let's skip this part. You have dispersants, fluid loss control, loss circulation agents. So these are kind of very similar to drilling fluid part that we had as well. Okay. So you can go and read all these. There are basically very much more detailed in the book. So we are not gonna go over them because you will not remember all these things after you finish this course. But just know that very similar to the drilling fluid, there are those additives that needs to be added to your cementing in terms of accelerating the setting time, changing the viscosity, changing basically the properties such that you don't lose the cement into high permeability formation, the loss circulation problem, right? And all those basically things, right? Now, how does the cementing job is done? So there are multiple stages for cementing. Depending on the company, they do it differently, but usually what we have is basically we inject spacer fluid into the system, into the wellbore, basically, right? That spacer, there it has two basically duties. One is one of the function of this basically fluid is to clean the wall from the drilling fluid. So as it moves down, it will clean the wall of your casing. And also it puts a space between your cement and drilling fluid, because initially inside your casing, you have all drilling fluid, right? So you have drilling fluid. Then you basically inject your, and let's say this is your annulus here, right? You inject your spacer or displacement fluid as well. Basically, displacement fluid job is to remove the drilling fluid, right? So it will basically be injected into here. The drilling fluid will go into your annulus. At the same time, it can clean the wall of the wellbore and also the wall of the casing, and also have give you the space between your drilling fluid and your cement. You don't want your cement and your drilling fluid to be in direct contact with each other. Okay, so a spacer basically provides that, right? Now, the process for this is different, but these are in this slide. What you see is basically what type of fluids are involved here. There is a spacer fluid, there's a displacement fluid. There is, of course, your cement slurry that is basically going to be injected, right, into the annulus, right? And these are basically the main fluids that are going to be involved, right? Now, what type of equipment we have this is basically called the cement head that is being used for cementing jobs. The cement head have multiple components. One of the components that is really important, I mean, not one, two components that is important in this cement head is the top, is called the top plug and the bottom plug. So these two components inside this basically cementing equipment, which will be installed at the surface when they want to do the cementing job, are really important. Now, the powdered cement and the water will be mixed at the surface of your, basically at the field, at the wellhead, right? They will be kind of mixed. The slurry is created. The slurry will be injected through this cement head that it will be installed on the wellhead. Okay, now this cement head has multiple components, but the most important parts are a bottom plug and a top plug. Okay, so these are the two main important part of it. So what does they do, and what are the differences between the top plug and the bottom plug? The bottom plug is basically the responsibility of the bottom plug. Once you want to start injecting your cement, the first thing that goes into the wellbore is the bottom plug. So what it does, it goes and remove all the drilling fluid which is inside your casing and guide them into the annulus. Okay, so cement, this bottom plug starts from the surface. It is released from that cement head to the wellbore. Okay, and as it goes down, it removes all the drilling fluid until it reaches to the depths that that's the end of your casing that you wanna basically cement. Okay, so it goes and it will be set there, right? And then you inject your cement. After that, sometimes you want to inject your spacer again, right? As I mentioned, you want to inject your spacer. It will clean the casing, right? And it will also put a space between your cement and drilling fluid. And then you inject your cement to the volume that is being required, right? Once you reach that volume that you need to do the calculations for, that top plug will be released. Okay, so the timing that you need to release your top plug from the cement head can be calculated exactly based on the number of surface pump, cement pump strokes, right? Because you do the calculations beforehand, right? You say that, okay, I need probably 500 barrels of cement to be injected. Barrels, what did I write here? You may want to say that I have 500 barrels of cement needed for this job, right? Because that will fill all the annulus for me. And I have a cement pump that, let's say, inject at 5 barrels per minute. Then you can determine how long you need to pump and then what time to stop pumping, right? And once that is done, the top plug will be basically released. Now, the difference between the top plug and the bottom plug is that the bottom plug have a rupture surface. Basically, it has a rupture area on it, which once the cement reaches to the bottom plug, it's like a one-way valve. Remember when we did the calculation for what was that? The axial tensions on the casings, right? On before the hydraulic chapter, we were talking about a float shoe at the bottom, which is basically a one-way valve. It's not here though. It's float collar. It's basically here. This part basically. It's a one-way valve, and that allows the cement basically to pass the bottom plug and goes to the annulus. The top plug, however, it's basically solid. I guess I have a picture. These are the centralizers. Let me see if I can find that picture. Yeah, so it's a solid core. So the top plug does have a solid core. The bottom plug has a ruptured disc. So once the cement reaches here, it can pass. It's a one-way valve. The cement will not be able to come back because it's a one-way valve. And it will go to the annulus. And once you have all your cements between the top plug and the bottom plug, once your top plug reaches to the bottom of the wellbore, then the pressure at the surface will increase significantly. So you can monitor the pressure at the surface, and that's the time that you need to stop, basically, right? And then you leave it there until the cement in the annulus is set. Okay, you will have also, so I mean, if I want to draw the wellbore exactly right on this, you will have some volume of cement here at the bottom, and the rest will go all the way to your annulus, right? And once you want to start, once your cement is set, right, you want to restart drilling, what you do is you drill through all these components. And that's it, right? These are basically the main process for the cementing. This is, of course, cementing the casing. There are more applications of cementing, right? One application of cementing is that you want to abandon a wellbore, right? So you have produced from a wellbore, a reservoir. That reservoir is not producing anymore, or the production is not enough. It's not economic. You want to close that pass for the fluid to enter your wellbore. You basically do a plug cementing, which you put a plug of cement at the bottom, and that way you abandon this wellbore, right? Or maybe this formation. You might have some other formations that are still producing. So you can basically have this cement plug preventing the flow of this formation. Okay, so that's called cement plugging. The process that I described was related to the cementing of casing. Okay, another application could be, you might have some formations that are very high permeable, right? And you may lose basically all your drilling fluid while drilling, right? One way of doing it is basically to squeeze cementing, it's called. Squeeze cementing. And you will squeeze cement into this high permeability formation and block basically them from basically getting all your drilling fluid into them, and that will prevent your lost circulation. So this is for lost circulation applications. But all the focus, I think, in this, chapter will be on casing cementing and how to calculate, the volume and things like that. Okay. Any questions so far? Nope. Alrighty, so these are the cementing equipment. They basically come on the truck, the mixers, the hooper, and everything that basically mix the powdered cement with the water. And they will be basically the cement pump. And these are the Halliburton. Halliburton is basically the company that is one of the main and famous companies who does the cementing. And if you remember Christine, who did the presentation for us, she was basically the cementing person in Halliburton, working for that company. So she has a lot of information on that. She came actually, I think 2 years ago to the campus, presented what they do. Anyway, let's go procedure. So the procedure is basically here. It's kind of a more detailed procedure, practical than what I said, but basically the process is the same. You mix your cement, you do the pressure testing, make sure that everything is working. You pump the spacer that basically removes the spacer will move your basically bottom plug, right? The bottom plug reaches your bottom hole. And then the spacer is on the top. Then you start to inject your cement, and the top plug then will be dropped, right? And then you start cementing set time, and whatever timing that is, 8 hours, 10 hours, 12 hours until your cement is set. And that basically that's another picture of the location of all those components that we were talking about during a cementing procedure. All right, so let's not do the calculations today. Stop at this point. all the calculation, you didn't see any equations because all the calculations that we do for the cementing are volumetric calculations. So they are pretty straightforward, kind of. You don't need any specific type of equation for calculating the cementing volumes and things like that, because it's all about volumetric calculations and volumetric balances that we do. Okay. The only part that you might need basically more information is how much water you would mix with your cement, and that we talked about it. And we will talk about it again when we do the calculations. All those numbers that you would require are basically in the tables in your book. Depending on what type of cement class we have, I'm looking for that table, you would mix different volumes of fluid, right? Yeah, so this is how much volume of water you would need with different types or classes of cements, and how much slurry basically it will provide. What would be the density, the resulting density if you mix that cement with this much of water? What would be your final density of the cement, right? All right, so any questions?
Nope.
All right, so if no question, let's stop here for today, and you guys go get to your projects, finish the project, and we will have the presentation on